everyone to One Take Wednesday. We're doing this entire video in one take with no editing, and there's all sorts of distractions, and we're hanging out outside, but we'll see how it goes. We're talking about graphs of quadratic polynomials today. So let's get started. Off to the side you see the graph of the equation x squared plus 2x minus 8. This also is the graph of x plus 4 times x minus 2. You could make this graph on Desmos or on your calculator pretty easily by just typing up either one of these. I want to call your attention to the curve that's formed here. This is called a quadratic or a parabola. And parabolas have a lot of different features that I want to call your attention to. So all graphs have a highest point or a lowest point, and so the highest or the lowest point in this graph is called the vertex. And so that's an important point to find, and it'll be the main idea of today is how do we find that. These graphs are also symmetrical, and so there is an axis of symmetry that goes right down the middle, and you can find the axis of symmetry by looking at the numbers in front of the x squared and the x term, and so the a and the b as we call them. A couple other features that this graph has that aren't going to be super important today, but eventually we will be interested in, is these graphs also have, where'd they go here? They always have a y-intercept. The y-intercept is where the curve crosses the y-axis. That's this number right here. And these graphs also have roots. I can't find, maybe here they are? Yeah, here they are. So where they cross the x-axis, those are called roots, or sometimes they're called zeros. And again, that'll be an important idea, but not so much in this video. What I want you to realize is that these two different forms, standard form and factored form, can tell us different things about the graph. You probably have this in your notes already. Standard form is when it's x squareds and x's and numbers. That's easy to add and compare and look at the degree. It also helps us with the vertex and the y-intercept. In the next video, we'll focus on factored form and what it can tell us, but primarily it helps us find those roots. So let's look a little more carefully at standard form. So standard form is when you've got something x squared and something x's and a number. And here are two different examples. First thing that standard form can tell you is if a, the number in front of x squared, if that's a positive number, then that means you're going to have a parabola that opens up. My math teacher said, it's smiling, it's happy, it's positive. And so it works, I guess. If a is a negative number, then it's frowny and sad, and it will open down, as in this example over here. So a little bit more carefully, we can find the line of symmetry. The line of symmetry we can find using this formula, negative b over 2a. And I hope that formula sounds a little bit familiar to you because that's part of the quadratic formula. Specifically, it's the first and last part of it. You can remember it by way of the song. X equals negative b plus or minus a whole bunch of other stuff that's not important over 2a. That's the line of symmetry. And so this graph looks like it has a line of symmetry centered around negative 4 maybe, and that's because if you tried to use this formula, b is an 8, so we'd put that up here, and a is a 1, and so negative 8 divided by 2 ends up giving us negative 4, exactly where I would predict that line of symmetry to be. In the red graph, it looks like it has a line of symmetry at 3, and again, if you use the formula to find that, you would put in a 12 for b, and a negative 2 for a down here, and negative 12 divided by 4 ends up equaling a 3, exactly where it should be. So the next important feature about these graphs is the vertex. In fact, that's probably the most important feature. And to find the vertex, you first figure out what the line of symmetry is, and then you take that x-coordinate and you plug it into the equation to figure out what the y-coordinate would be. And so in this green graph, it looks like the y-coordinate probably is going to end up being a negative 6. If we didn't know that, if we didn't have a graph already, we could find it by putting in the -4 that we had gotten earlier for our line of symmetry and squaring that. 8 times -4 plus a 10. You do all that calculating, you end up with a -6. Again, just where the graph suggested it would be. If you did the same sort of thinking with the red graph, you first find the line of symmetry, which is 3. And then when you plug that in for x, -2 times 3 squared is -18. 12 times 3 is 36. And when you subtract 10, you get an 8. So let's look at a couple of different examples, and we'll be done for the day. Let me move myself a moment. So this graph, or these questions say, tell whether this graph is opening up or down, and then where the vertex is. So to find whether it opens up or down, you look at the a value. And so in this particular case, the a value is 1, a positive 1. And so since that is a positive number, that means this is definitely a happy graph and opens up. Now, to find the vertex, we have to do this in 2 steps. We need to first of all figure out the line of symmetry. And to do that, we use -b over 2a sort of thinking. And in this case, b was the -8 and a was 1. And so -8 times negative is a positive 8. 2 times 1 is 2. 8 divided by 2 is 4. And so now that we know the line of symmetry is at 4, that means we know our vertex is 4 something. In order to find the y-coordinate, we take that 4 and we plug it into the formula here. So x squared, so that would become 4 squared, and minus 8 times 4 and plus 3. 4 squared is 16, 8 times 4 is 32, and we subtract them and add 3, we end up with a 13. And so final answer for the vertex is 4, -13. And with that information, we can draw a pretty accurate graph of this actually. So here is a little xy plane, and if we wanted to make a graph of this, we can find the point 4, -13, and so that might be over a few and down a bit, and put our vertex there. Make that come up to the front a second. Oh bother. This is why we don't always do one take Wednesdays. Alright, so there we go. Let's get rid of some of this extra stuff so you can see the picture. So here's what our graph would kind of look like then. Goodness, what a mess. All right. Well, we'll do a better job of this when we have a more edited video tomorrow, but you get the idea, I hope. In this problem, if we wanted to know if it opened up or down, again, I would look at this first number, and this a is a -2, and so this is a graph that is definitely, oh bother, goodness, there. This is a graph that's definitely a sad graph, and so let's flip it upside down. If we wanted to know where that vertex is, then we have to do the calculations of -b over 2a. And b in this case is sneaky. It's an invisible 0 because there's 0 x's. A is -2, and 0 divided by -4 is 0. And so that means our vertex is 0 something. And to figure out the something, we take a 0 and plug it in for x. And so when we plug a 0 in for x, we get -2 times 0 squared minus 5. That's 0 minus 5, and that gives us a vertex of 0, -5. So we got one last equation for you. I would encourage you to pause the video and try to find the answer to up or down and whether it's what its vertex is. I'm going to reveal the answer in just a second and see if I can get myself back up on the screen for a goodbye. So I hope you thought to put in a negative 10 over a 2 times 3 is 6. In this case, that works out to be kind of an awkward number, negative 1.7-ish on the calculator. That happens sometimes. And then to find the rest of the vertex, you plug in that negative 1.7, or I did the exact fraction, negative 5/3, to finish this off. Negative 5/3 times negative 5/3 times 3 plus 10 times negative 5/3, all on a calculator, worked out to be negative 8.3. And so that means the final vertex is here at negative 1.7 and negative 8.3. If we want to make a graph of this, give this a shot again, see if we can make it work. The graph is definitely one that opens up because it's got a positive a, and so it's happy. And so now I'm just going to try to drag this to about the right location. So negative 1.7 would be backwards a bit, and negative 8.3 would be down a bit. And so I would expect a graph that looks something kind of like this. Again, we'll get into more specific graphing in a future video, but I hope that gives you a little bit of a taste as to what sorts of things you can expect to see with polynomials and how you can find the most important point. Thanks for hanging out with me on a Wednesday. Sorry the video got a little bit awkward in the middle where I couldn't make those curves show up right, but I hope you have a wonderful rest of your Wednesday, or I guess it's probably Thursday by the time you're seeing this. So, see ya.